Alrighty, so question 13. We are looking at some summation of sequences. The notation. This is one of those questions where I feel like, depending on your confidence level, in an exam, this comes up. It looks pretty heavy, doesn't it? You've got the summation symbol, which some people get confused by. You've got a natural log in there, which people generally don't like, and there's no numbers, it's K, L, M, P, so it can be quite off-putting to look at this question. But when you start just realising what you're supposed to do and just following your instincts, it becomes a lot easier than it looks. So there's a side note here, just to put everyone's, if you don't like ln, then remember, lnx is just natural log. So we're talking about logs in base E. Excuse me. So we're just talking about logs. So we need to bear in mind that we're dealing with logs, because log rules comes into this question to make it easier. The notation, let's just have a look at it. So we're going to put the values of 1 through 11 into this sequence sort of generator and see what terms we get out, and then we're just going to add them all up. That is basically it. So we're going to start off by putting in 1 where n is. So n is 1. So we're going to get ln and then p. So the 1. I'll put the 1 in. Plus, because we're adding it all up, put 2 in. ln p squared. And then just carry on all the way through to 11. Alright, so there we go. And so on, all the way up until ln p to the 11. Alright, so those are our terms. Now you've got to add them together. And to be honest with you, it doesn't look that intuitive, how you're supposed to add those together. When you start using the log rules, so there are those powers that we had, the 1, the 2, the 3, the 4, the 5, etc. Put those out to the front, and I'll write it underneath what that looks like then, because it makes it feel much more intuitive. Sorry, was that ln? My handwriting is terrible on these videos, but I do have this pen that I'm trying to write with that is just not very well calibrated. So start putting the powers out, and you start to get this sequence using the power rule. Alright, so we're just going to add these up because we've got a whole load of LNPs. All the way up to 11 LN. That is an LN, by the way. LN. God, terrible handwriting. LNP. So you've got 1 LNP, plus 2 LNP, plus 3 LNP, plus 4 LNP. But you've got to add up the numbers 1 to 11. Okay, and that will give you the total. And if you add up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, collectively, you're going to get 66 LNP. And that is the final answer. Okay, that is what they want. The second part, B, show that if you were to have, instead of just p to the n in here, so you've got 8p to the n, then that equals 33 ln 2p squared. Alright? So you're looking at this. It's slightly different to what we had before, but remember what we spoke about. This is rules of logs. Okay, so we're going to end up with, let's think about this as a log term. I'll write it down here. If we had ln 8p to the n, where does that come from? In relation to our first one, p to the n, we've got the answer to p to the n, so it'd be useful to separate that from the 8. So we can have a look at that. We know that the rule for if you've multiplied something together, that comes from, 2 log terms being added together. So if we think about it like this, then we can think about our sequence in 2 separate parts here, and we're going to add up all the parts. Well, we've got the answer, still the same values going through, n equals 1 to 11, so we are going to be putting 1 to 11 through here, and for the second part of this, now we've separated it, we have the answer to that bit. The total of that is still going to be 66 lnp. Alright, it's just this first bit here. There's no actual n in the bracket here. So when we're putting through our values of n, then we're just going to get one of these for every term that we get out here. So for every one of these terms, we're going to have an extra ln plus 8 on the end of each of these terms. So we're actually going to end up with 11 lots of ln 8s. We're going to end up with 11 lots of ln 8. Okay, because we're going to be adding one on to each of these terms because of this sequence. So the second sequence is basically this sequence plus every time you have a term, you're going to get ln 8. And then this one plus ln 8. And then this one plus ln 8. And you're going to get 11 ln 8s all the way along. So this is our final answer, but they don't want it written in this format. So we're going to manipulate this to give us the answer that they want here. So you're going to have to look at it and use your intuition. So I don't have p squared or a 2 here, and I don't have 33 either in any of the coefficient kind of spots. So how are we going to generate that? 11. To get to 33, I'm going to need to times that by 3. So where's that 3 going to come from? And also, I don't want an 8 anywhere in my final expression in the bracket. So I'm thinking about this 3. Where's this 3 going to come from? The power rule will let me put a 3 at the front. So I can actually do this part here, 11 ln 8. I'm going to change the 8 to 2 cubed. That will give me the 3 that can then go out to the front and multiply the 11. So then I have 33, which is perfect because that's what I want. ln 2. Also have the 2 now. Alright, but I need this p squared from somewhere. Plus, so this one, if I'm looking at this, I've actually got too many. I've got 66 here. I do not want that. I want 33. So if I take a factor of 2 out of this, alright, so take a factor of 2 out. Where's that 2 going to go? 33 times 2. But I'm not going to write times 2 because I'm going to take that 2 and I'm going to put it back up into the power spot here. So there is my 2. Alright, so that could times that to give 66, but I've just undone it to put it there. Now I have the 2, now I've got the p squared. I can add these together. If you're adding, then you multiply what's in the brackets to combine your log term into 1. So I get ln 2p squared is the final answer. Alright, so that's what we had to show. Last part, we're trying to find a set of values which make this kind of sequence less than 0. So the summation of this sequence less than 0, we're going to use our answer here, I suppose, to start with this, because that is the actual answer. When is that less than 0? So when is 33 ln 2p squared, when is that less than 0? Divide through by 33, and we get ln 2p squared is less than 0. Alright, so we're basically sort of saying, right, when is this going to be less than 0? When is it going to be negative? Well, for things to be in here, I mean, look, you've got something squared, which is going to be a positive value, and then you also timesing it by 2, so it's still positive. So this is never going to be a negative number in here, which is fine, but it means it still has to be less than 0. The graph, you may be aware of the graph, it should be, of the natural log, it looks something like this. So, a quick sketch here, e to the x is like this, and the natural log is a reflection of this graph in the line y equals x. This should be knowledge that you are aware of. So then it goes up here and it looks like this. Okay, so that's e to the x. This is ln x. God, I can't write ln for some reason, sorry. And we're looking for when is it less than 0. Well, we've got an intersection here, and you should know that ln of 1 is 0. So that's an x value of 1. So it's going to be between 0 and 1 in this spot here. So we're going to get 0, the 2p squared is got to be greater than 0 because the graph never actually goes past y equals 0, and also has to be less than 1 because at 1 then it becomes positive. Alright, so we're looking for negative, negative parts to this graph, negative y values here. So we can just solve this inequality now. So we know that we're going to end up, let's do it separately. So we know that p squared, 2p squared, excuse me, is greater than 0, divide by 2, p squared is greater than 0, square root, so we know that p is greater than 0. One solution, p is greater than 0. Other side, let's check this out. So p squared is divided by 2, is less than a half. P squared is less than the square root of a half. So p is less than, square root of 1 is 1, square root of 2 is root 2. So our final solution is p lives between 0 and 1 over root 2. And we need it in set notation. So p is our set. So, I mean, the set notation is quite tricky to get right. So we're going to be talking about a set. Give the set a name. The values of p are basically between between 0 and 1 over root 2. Alright, so I kind of hope that's been helpful in some way, and let's get on to the next video.